Hey everybody, Steve Hedden here from Top Quadrant. Today we're going to be talking about vector databases and how we're using them in Edge to do two things: AI linking and vector search. And I'll talk about what that means and then I'll show what it looks like. So a vector database, if you don't know, it's a database filled with vectors and a database that can store vectors. And why that's important and why that's useful is that once you store your data as vectors, you can do similarity between vectors very easily in vector space, meaning the how close those two numbers are together, and send it a natural language prompt or a string, and then find all data that's most similar to your prompt. The way that those vectors are created is really where the magic happens, and that's using AI, and it's one of the core components of LLMs that we use today. So the two things I'll be showing today are what I just described: alignment of terms, whether that's two things that are the same, which is often called entity resolution. These are two different uh, terms within your graph that actually refer to the same thing. Let's map them together. Or, and this is what I will show today, is across two different kinds of terminologies. So like a glossary of business terms and a data catalog of column headers. We want to start mapping and linking those two things together. And that is what we'll show. The other part of that is search. So I want to search my graph for this node or this term, and I can use a vector database to get that initial response and then refine it using all of the relationships in the graph. And so that's what I'll show today. Quick visual of what that looks like is here we see TopBraid Edge is a product of Top Quadrant, and within our architecture now we have this vector database. Those two things are connected. That's where the AI linking comes in. It's it's called this over here. It's called this in Germany. Those are the same thing. AI can provide a suggestion, and then it's up to the human user to either accept or reject that suggestion. At the bottom there, you can see that vector search where you can send a term to the vector database and retrieve the most similar nodes or concepts or entities within your graph. That is really the foundation of things like GraphRag and agentic AI, where you can send a natural language query to your vector database, return the most similar entities, which have URIs, which then you can do all the graph stuff you would normally. So find their neighbors, find links between them, and anything else you want to do. That's where we can enable GraphRag. And I'll show a little bit of what that would look like in this demo as well. So without any more talking, let's get into the demo. Okay, so let's go into the demo. And for this scenario, what we're going to do is we're going to build a simple GraphRag app or a chatbot so that our data scientists can ask questions about what policies and data policies they need to be aware of. So they don't need to be bothering the compliance team all the time. So the idea is that they could just ask a question here, like which policies do I need to be aware of if I'm working with these data sets, and it would give them the answer. And why I say it's GraphRag is that we're going to return the results based off a retrieval against our graph, and then use an LLM to summarize those results. And so that initial retrieval, surprise, uses that vector database, but then we can also use everything we have in our metadata layer to um, include additional context based off those relationships. So, for example, let's say I want to say what policies are related to branch name. Say I'm working with the data column headers, something about branch. I'm working with data about bank branches. This will return a data asset called branch name, but we haven't mapped it to anything yet. And so it doesn't have anything else. It just has the branch name. This is, by the way, this is a fictional bank we're working with called TQ Bank. But yeah, it applies to any data set, of course. It's just a demo data I'm working with. You can see here, though, the response, the initial result, that's the vector database giving us the branch name. So it looked through our data assets and said, this is the column header that's most similar to that thing you just asked me about. And then at the bottom, that's the LLM trying to summarize the results. And it's not coming up with a good response because it doesn't have any context. You didn't give it anything other than branch underscore name. So that's not going to work very well. What we need to do is actually build those mappings in our metadata. So let's go into Edge and use AI linking to link those things together. This is our glossary. So you can see all the different TQ Bank glossary terms. The one that we've highlighted here is bank branch. And so this is the one that we're interested in. This would be the thing we would theoretically want that data catalog term to be mapped to so that we can infer all of those policies. And you can see here, as I mentioned earlier, this glossary term is already mapped to a policy. And so we don't need to do that stuff. We just need to look at the relationship between the data asset and the glossary term. So when we look at our data assets, this is essentially a data catalog, a list of a bunch of different column headers, less intuitive naming, right? So these can be underscore, camel case, all kinds of things can be happening in the way data scientists name their data. And we can use this to start trying to generate suggestions for what we might want to map these column headers to. So I want to look at that branch name, the one we were just looking at, and I'm also going to include this one, covered bonds, just as an example. So let me run problems and suggestions, and it'll generate results for us or suggestions for us. So you can see here, these are the two things we just looked at. Before we get into branch name, I just want to highlight covered bonds because I think this is pretty cool. Yeah, it mapped covered bonds, the column header, directly to covered bonds, the glossary term, which is totally what we would expect. You could just do string matching, right? That's not that exciting. What is interesting about the vector technology is that it also suggested interest-bearing debt security, which you could see has nothing to do string-wise with the term we were searching or the source we were starting with. And so it's up to the user, the human, whether or not to apply that, whether or not those things we do want to map together. But those are pretty close terms semantically, yet have nothing in common in terms of characters and strings. Okay, but the one we're interested in, just to show the full demo, is the branch name. We want them, it's suggested map to bank branch, which makes a lot of sense. That's the glossary term we were just looking at. Now I can just press one button. It is now applied. Those two things are mapped. Why does that matter? Because we can go back to our policy pilot and ask the same question. And so now it's going to say, found that term. It's connected to that glossary term, which is connected to this requirement. Now, when the LLM summarizes it below, it has actual context to go on. It's saying if you're looking for this column header, you probably need to be aware of these policies. This is what you need to do about them. So that's how you can use metadata to map things together. In this case, we did data assets to glossary terms, which were already connected to policies so that you can ask questions using natural language about data and get answers about policies. Please try this out. Let us know what you think. If you're an existing customer, submit tickets for improvements as you would normally through the service desk, or reach out to product directly. And if you're not a customer, reach out to the sales team or product directly, and we'd love to work with you.